Hey everyone, this video is about solving exponential equations with the same base. It is target 7 from Unit 5B. We're going to start off with reviewing the concept checks. So get out your packet for concept checks. We're going to do concept check number 2, day 1. So there should be 4 problems there. Then we'll do some notes. You should get a handout for that. And then your homework will be a worksheet. All right, so these are the 4 problems on concept check day 1, concept check 2. They're all about exponents, which we've already done. So hopefully they're not too difficult for you. So let's just get started here. And let me remind you that when you are solving or rewriting something that's in exponential form like this one, you need to rewrite it so that you have the negative exponent down in the denominator. So that one would just become 5 over x to the third. All right, then this one, you are going to distribute that power. Sorry, I'm feeling like we've already done these. So if we have, then just skip past them and do day 2. And maybe I've opened the wrong one, but if I haven't, then go for it here. So this is going to be 2 to the third, a to the third, or a to the ninth, and then b to the third, which becomes the whole thing 8, a to the ninth, b to the third. All right, this one here, C, we start by distributing, or not distributing, but multiplying the negative 5 and the 2 together. So you get negative 10. And then when you have the same base, you add the exponent. So this is x to the 7th. Okay, finally, this last one here, you're going to start by reducing the 12 over 15. So the 12 over 15 can be reduced by 3. So that's a 4 and a 5. And then you're going to subtract the powers here. So the 8 is bigger than the 5. So you're going to do 8 minus 5 and give you x to the third, but in the denominator. And then the 3 is bigger than the 2. So you'll do 3 minus 2, which is 1, but that goes in the numerator. So hopefully that all sounds familiar because we did do that week right after we came back from break is when we finished this. All right, moving on. So today's lesson is then about, excuse me, about solving exponential equations and getting those exponential equations to have the same base. So all of the problems we're going to talk about here, you can rewrite the problems so the bases are the same. So that first one is the easiest one here. So make sure you're copying these down onto your note sheet. Take a drink here. So you're going to rewrite 16 as 4 squared. So they have the same base. And then you look at the powers and you set them equal to each other. So you have x equals 2. Done. The second one's going to require a little bit more work, like an extra step here. So we're going to start by rewriting 125 as a base of 5, and that's 5 to the third. Now, if you don't remember all of these powers, you're probably going to need to do a little bit of extra reviewing on your own to help you remember. Really, like I would say anything to the third power 1 through 6, and then anything squared through 12. You'd want to know those. Okay, now we have the same base. Sorry, you guys. So I can set the powers equal to each other. So 3x minus 7 equals 3. Add our 7 and divide by 3. And you're going to find that you're going to have a lot of fractions, and you can just leave them as a fraction. There's absolutely nothing wrong with that. All right, third one, this is why we actually did the review that we just did on the concept check. So 27 is 3 to the third, and 9 is 3 squared. So both of them need to get rewritten with a base of 3. And then because they already had a power there, you're going to need to distribute the power. So it's 3 to the 3x minus 12 equals 3 to the 2x plus 2. And now we have same bases, so we can set the exponents just equal to each other. So 3x minus 12 equals, 2x plus 2. Subtract our x and add our 12. And so you get x equals 14. Now, obviously, if you're not sure if these are correct, you can just substitute each power in. Like for this one here, for instance, if you put 10 thirds in for x, I'll just show you what this one, since it's a fraction. So you would have 3 times 10 thirds minus 7. The thirds, the third and the 3 cancel, and you have 3 to the 10 minus 7. Sorry, 5, not 3. And then 5 to the 3, we already know is 125. So you can check it that way to see if you did it right. All right, moving on to the next problem set. So 4, 5, and 6. So this first problem here is 1/2 to the 3 minus 4x equals 2 to the 5x. So the 2 is already fine over here. We need to rewrite the 1/2 as a power of a -1. So 1/2 becomes 2 to the -1. So now I can distribute that -1, and I have 2 to the -3 plus 4x equals 2 to the 5x. And just like before, once the powers are equal, or sorry, once the bases are equal, you can set the powers equal to each other. So I have -3 to plus 4x equals 5x. Subtract 4x, and we get x equals -3. Okay, second one. 9 to the 2x plus 3 equals 3 to the 8x over 3 to the 5x. So we've got two things we need to simplify here. The first thing that you want to do is get the 9 to have a base of 3. So I'm going to rewrite the 9 as 3 squared, and then it's times 2x plus 7. And then when you have a problem where the bases are the same, but you're dividing, this is just like in the opener. This is when you subtract the exponents. So this becomes 3 to the 8 minus 5 is 3. So 3 to the 3x. So this simplifies to be 3 to the 4x plus 14 equals 3 to the 3x. So again, the powers are equal. Subtract 3x, you get x plus 14 equals 0. Subtract 14, and we get x equals -14. All right, last problem. So this one has several things we're going to have to fix. The first one that jumps out at me is I have that root there that I don't like. So the cube root of 2, I'm going to rewrite that as an exponent that's a fraction. So remember, when you have this situation where you have some sort of radical going on, the power on the inside part goes in the numerator of your fractional exponent, and the number out here in the little crook of the radical, that goes in the denominator. So you have 2 to the 1/3. And then the 16, I also need to rewrite that as a base of 2, and 16 happens to be 2 to the 4th. And then I'm going to multiply that 4 by x minus 5. I need another drink. Sorry. All right, this becomes 2 to the 4x minus 20 equals 2 to the 1/3. So now I have just the powers equal 4x minus 20 equals 1/3. And I'm going to start by adding 20. And we're going to do some fraction work here as well. So I have 20 and 1/3 if you add them just like that. But it's going to be easier to divide by 4, or more likely the way you would see the answer anyways, if you rewrite this as an improper fraction. Mostly I'm thinking about how you would see the answers, like on multiple choice. So to rewrite this as an improper fraction, you do 3, the denominator, times the whole number here. So 3 times 20 is 60, and then you add the numerator. So 3 times 20 is 60 plus 1 is 61. And then that gets divided by the original fraction of 3, or denominator of 3. Now you can divide by 4, and you're really just multiplying the denominator by 4. So you're now going to have 61 over 3 times 4 is 12. So you have 61 over 12. Okay, so those are the 6 problems I wanted to go over with you. At the bottom of your handout, there should have been some space there. We were going to do some stuff together in class, but I just want you to take a look at these 2 problems. Pause the video and look at them and try them out. And then I'm going to tell you what the answer is once you have paused the video. Okay, so for the first one, hopefully you paused that. The first one, I'm going to turn both of them into a base of 2. So 4 is 2 squared, and 32 is 2 to the 5th. I'm going to distribute my powers. And set the powers equal to each other. Oops, it's a 3. Well, it's a good thing I did these with you because the answer doesn't appear to be there. So I subtract 4x, I get 1x. Subtract 1, I get 2. So, hey, good news is we did it together. Bad news is the answer is not there. So we're going to call it 2. And then the second one becomes 5 squared. So 5 to the 2x plus 2. And I'm going to subtract the powers here. So this is going to become 5 to the 4x. See if I got this one right at least. 2x plus 2 equals 4x. Nope. You know what? I think this is what happened, you guys. I think I put the answers in the wrong spot. Yep. And if I were feeling better, I would redo this video and fix this for you, but I'm going to hope that you'll be understanding. So actually what was supposed to happen is when I cut and pasted the answers, they were supposed to be like this. So this answer was a 1 and this answer was a 2. All right, hope you forgive me on that. That's the end of the lesson, and your homework is a worksheet.